Welcome back to the deep dive. It is Tuesday, February 24th, 2026, and today we are unpacking the week that was specifically the week of February 15th through the 21st.
Right, the quiet week.
Yeah, exactly. If you were just, casually scrolling through your newsfeed this past week, you probably thought it was a pretty quiet one for Meta.
Oh, absolutely. On the surface, it looked like a total ghost town. There were no big keynotes, no flashy consumer product launches.
No VR headsets being shown off on stage.
Exactly. It was really easy to miss if you weren't paying close attention.
But when we actually started digging into our sources for this deep dive, the archives of research papers, the regulatory filings in Africa, the massive infrastructure contracts, it paints a completely different picture.
It really does.
It kind of feels like everyone was looking at the showroom, but all the real action was happening back on the factory floor.
That's a great analogy. This week wasn't about the shiny object at all. It was really about the industrialization of Meta's AI engine. We're talking about massive foundational shifts in how their AI sees the world, how it processes data, and crucially, how they are laying the physical pipes to run this stuff at an insane scale.
Gigawatt scale. And also how they're deploying that intelligence in some pretty surprising places. We've got everything from performance smart glasses launching in India to, well, a potential resurrection of facial recognition technology.
Which we all thought was dead and buried.
Right. It's a classic Meta week when you really look at it. You have this rapid technical scaling colliding right up against legal and ethical walls. Our mission today is to sift through all of these developments and connect the dots for you, the listener.
Sounds good. Where do we start?
Let's start with the brains of the operation. We got our hands on a research paper released around February 18th regarding something called Xray-Visual, and the numbers here are they're staggering.
They're completely astronomical. This is a new unified vision model architecture from Meta Research. To train it, they didn't just scrape a few public data sets. They used 15 billion image-text pairs.
15 billion?
Yeah, and on top of that, 10 billion video hashtag pairs, all sourced from Facebook and Instagram.
Just to contextualize that for you listening, that is effectively a massive chunk of the entire visual internet. That's the advantage of owning the social graph, right? The data is just sitting right there on their servers.
Right. But usually having that much data is actually a huge problem.
Because it's messy.
Exactly. It's what researchers call label noise. People tag a photo of a dog with Sunday vibes. The AI gets confused because it has no idea what Sunday vibes is actually supposed to look like.
So traditionally, engineers have to spend months cleaning that data, right? Like scrubbing out the bad labels so the AI doesn't get confused.
Yes, but at 15 billion images, you literally cannot clean it. It is humanly impossible to filter that manually. So the breakthrough with Xray-Visual is that they just stopped trying to clean the data.
They just threw it all in.
They designed a three-stage pipeline that assumes the data is garbage from the start.
So they taught the model to learn through the noise.
Precisely. It's a unified model that learns to identify the signal, the actual dog in the picture, amidst the noise of all those bad hashtags, and it does it without human intervention.
That's wild.
But the other fascinating part of this paper is how they managed to process it without completely bankrupting themselves on computing costs. They use something called EVI.
Oh, we love a good acronym on this show. EVAVIT. Let's unpack that. What does it actually do?
It stands for Efficient Vision Transformers. Think about how you read a textbook when you're cramming for an exam. You don't read every single and with the exact same intensity as the bold vocabulary words, right?
Right. I'm skimming. Ignore the fluff.
Exactly.
Yeah.
Traditional computer vision doesn't do that. It looks at every single pixel block or token of an image with equal importance, even if it's just a blank white wall behind a person's head.
Which seems incredibly wasteful.
It is. It burns so much compute. EVIT allows the model to identify what they call inattentive tokens, the boring parts, and just drop them.
So it literally ignores the background wall and focuses all its processing power on the face or the object.
Correct. It creates a sparse representation. This allows them to process high-resolution images much, much faster. It's basically the difference between sounding out every letter on a page versus speed reading the paragraphs. That efficiency is really the only reason they could crunch through 15 billion images.
So they're making the AI see faster and more efficiently. But they aren't just looking at Instagram photos. There was another paper, NeuroMambal LM, that dropped on February 15th. And this one it felt like a huge departure from the whole social media company identity.
A massive departure. This is Meta applying their AI stack to hard science. specifically neuroscience and medical AI.
Wow.
Yeah, they're using this model to analyze fMRI data, functional magnetic resonance imaging, to understand brain connectivity. And the paper specifically focuses on identifying patterns in autistic brains.
So we're going from cat videos and hashtags to reading brain scans.
And the architecture they chose here is really fascinating. They're using the Mamba architecture.
Mamba. Okay, aside from being just a cool name, why does that matter? Why aren't they using the standard transformer architecture that powers, ChatGPT and most of their other models?
There is a very specific technical reason, and it gives us a big insight into where AI architecture as a whole is going. The transformer architecture, the T in GPT, has a fundamental flaw when it comes to certain data. It has what we call quadratic complexity.
In plain English, please.
Right, sorry. It means if you double the length of the audio or the video you want the AI to analyze, the amount of work the computer has to do doesn't just double, it quadruples. It gets exponentially harder and slower the longer the sequence gets.
Which is a huge problem for brain scans, I assume, because those are long, continuous streams of biological signals.
Exactly. Brain signals are continuous time series data. Transformers just choke on them because the memory requirements explode. Mamba architecture is completely different. It processes sequences in linear time. You double the length of the scan, you just double the work.
So it's a lot leaner.
Much leaner, much faster for long sequences. By combining Mamba with the reasoning capabilities of a large language model, they are effectively building an AI that can read a brain scan almost like a sentence. It really suggests Meta sees a future where their AI isn't just recommending reels, but potentially assisting in complex medical diagnostics.
That is a fascinating pivot. But sticking with the software side for just a minute, we also have to talk about Llama. We got version 3.370B and struck this week.
Yes, the relentless march of the version numbers. That was released around the 18th on Hugging Face and the Meta AI blog.
It feels like they update this thing every other week. What is the headline improvement for this specific version?
Coding and math. They benchmarked it on Human Eval, which is the standard test for AI coding ability, and the scores jumped significantly. But the real story here isn't just the benchmark score, it's the overall strategy.
Because they're still giving this away for free.
Right. This is commercial-grade code generation. A year ago, you had to pay OpenAI or Anthropic heavy API fees for this level of performance. Now Meta just hands it to you on a silver platter. They're basically flooding the zone with open-weight models that rival the proprietary closed ones.
And this ties perfectly into a report we saw later in the week regarding India, doesn't it?
It absolutely does. There was a joint report published by the Linux Foundation and Meta on the 18th. It projects the AI market in India will hit $32 billion by 2031.
$32 billion.
Yes. And they explicitly credit open source as the primary driver of that growth.
So by giving Llama away, Meta is effectively becoming the default operating system for the entire Indian startup ecosystem.
Exactly. If every new startup in Bangalore is building their products on top of Llama because it's free and highly capable, then Meta controls the foundational architecture the next decade of the internet in the global south. It's the classic commoditize your complement strategy. You make the base model free so you can capture the value elsewhere in the ecosystem.
Speaking of capturing value in India, let's talk about hardware, because this was a bit of a surprise to me. I think most people associate Meta's smart glasses exclusively with Ray-Ban, but this week, between the 18th and the 21st, they launched a partnership with Oakley.
The Oakley Meta Vanguard. Yes, this is a very specific tactical launch.
And it's only in India for now, right?
Correct. And it positions the glasses in a completely different category. The Ray-Bans are very much lifestyle. You wear them to a concert, you wear them to a cafe to take pictures. The Oakleys are strictly performance. They are targeted at runners, cyclists, athletes.
I noticed the sources mentioned integration with Garmin and Strava.
Right, so imagine you're running a marathon, and instead of having to break your stride to look down at your watch, the glasses just softly whisper your pace and your heart rate right into your ear.
That's pretty cool. But the killer feature, the one that really seems to matter for the Indian market specifically, is the payment integration.
Oh, absolutely. The UPI Lite integration.
For those listening who might not know, UPI Unified Payments Interface is the absolute lifeblood of digital commerce in India. It is how everyone pays for literally everything, from rickshaw rides to tea stalls.
And now you could do it with your face.
With your voice and your glasses. Right.
You walk up to a merchant's QR code at a shop, look directly at it, and just say, hey, Meta, scan and pay.
That is incredible friction reduction. You don't even have to take your phone out of your pocket.
And they localize the product perfectly. It supports Hindi voice commands natively, and this is the real marketing genius part. You can actually set the AI's voice to sound like Deepika Padukone.
One of the biggest Bollywood stars in history. That's a huge get.
It signals that Meta isn't just taking a US product and shipping it to India as an afterthought. They are fundamentally building for India. They clearly understand that voice-first computing is a massive opportunity in markets where literacy rates or just the friction of typing on small phone screens might be barriers.
We did also see a smaller update for the Ray-Bans this week. The real-time translation for French and German went live on the 21st.
Yeah, joining Spanish and Japanese. It's an incremental update, sure, but it reinforces that utility argument. They desperately want these glasses to replace your phone for specific, frequent tasks. Translation is a huge one for travel. It makes the device stop being just a novelty camera, start being an actual necessity.
But to run all these real-time translations and process all those instant UPI payment requests and train on 15 billion images like we talked about, you need serious hardware on the back end. And that leads us right into segment C, the infrastructure news.
The gigawatt scale reality. On February 17th, Meta and NVIDIA announced a massive multi-year infrastructure partnership.
Now, I feel like every tech company has some kind of partnership with NVIDIA right now, but the language in this announcement sounded, I don't know, a lot deeper.
It is much deeper. They are deploying NVIDIA's Vera Rubin platform across their data centers. But more importantly, they're doing extensive code design. Meta isn't just buying chips off the shelf and plugging them in. They are integrating NVIDIA's Spectrum-X Ethernet networking right into the core of their facilities.
Spectrum-X sounds like a supervillain space station. What is it actually doing?
It's all about networking. See, when you have 100,000 GPUs sitting in a data center, the bottleneck usually isn't the processing speed of the chip itself. It's the wires connecting them. If the chips can't share data with each other fast enough, the whole system just stalls out waiting for information. Spectrum-X is an Ethernet platform designed specifically for the insane demands of AI workloads. It drastically reduces packet loss inside the data center.
So it keeps the traffic moving so the brain doesn't freeze up.
Exactly. It allows Meta to actually utilize 100% of the compute power they're paying billions of dollars for.
Yeah.
And there was another really interesting layer to this NVIDIA announcement, confidential computing, specifically built for WhatsApp.
I saw that in the newsroom post. It sounds like a privacy feature.
It addresses a massive structural criticism of their AI push. WhatsApp is famously end-to-end encrypted. But if you want a server-side AI to help you write a message or summarize a group chat, traditionally, that data has to be seen by the AI in plain text.
So how do they solve that without breaking encryption?
They're building a trusted execution environment, or a T. Think of it like a secure black box sitting inside the server. The encrypted data goes in, gets decrypted only inside that box, the AI processes it, and then the result gets re-encrypted before it ever leaves the box.
So no one can intercept it?
Right. Even the Meta engineers or the cloud provider operating the server literally cannot look inside that box while processing is happening.
So it enables all these fancy new AI features without breaking the core promise of privacy.
Theoretically, yes. It is totally crucial for them because they clearly want to put AI into every corner of WhatsApp. But they simply can't afford to lose the trust of the billions of users who rely on it for secure communication.
That makes a lot of sense. But speaking of developers and compute costs, we skipped over a small but really important open source release on the 20th, Infra-RT.
Ah, yes. Infra-RT. This is an open source C++ runtime library optimized for transformer inference on both CPUs and GPUs.
Okay, that sounds super technical. Why should our non-developer listeners care about a C++ library?
Because it solves the prefill latency problem. When you first ask an AI model a question, there's that little pause before it starts generating text. That's prefill latency. Infra-RT reduces that lag by about 15 to 20% for massive models, like the 70 billion parameter Llama. But more importantly, it drastically lowers the compute cost of running those models.
So it makes the AI cheaper and faster to run in the real world.
Exactly. And by open sourcing it, Meta is handing that efficiency directly to every developer currently using the Llama ecosystem. It's another brilliant lock-in mechanism. If your base model is free Llama and your runtime environment is faster and cheaper than the alternatives Infra-RT, why would a developer ever go anywhere else?
That is a very sticky ecosystem. Talking about lock-in and ecosystem control, though. Let's move to segment D, safety, policy, and governance. Because while they're building these secure black boxes for privacy and speeding up their runtimes, They're facing some very serious heat from regulators.
It was definitely a rough week for their legal and policy teams. Let's start with the 2026 US Midterm Elections policy they released on February 19th.
Right, the new framework for political content.
It's mostly what industry watchers expected, but fully codified now. Very strict labeling. They are mandating the C2PA standard, which is essentially a standardized technical way to watermark AI-generated content. If you generate a political image, the metadata gets tagged and tracked.
And the ad blackout is back, right?
Yes. They are blocking all new political ads in the final week of the election campaign. The idea is to prevent a last-minute AI-generated surprise smear campaign that is too late to be fact-checked before people vote. They are also strictly requiring advertisers to proactively disclose if they used AI in their materials.
Which honestly seems like table stakes at this point in the generative AI era. But the regulatory pressure isn't just happening in the US. You mentioned the COMESA probe earlier.
Yes, and this is highly significant. COMESA is the common market for Eastern and Southern Africa, a trade bloc of 21 African nations. On February 17th, their competition commission officially launched an antitrust probe into WhatsApp.
What's the specific beef they have with WhatsApp?
It's entirely about the AI ecosystem.
Yeah.
The core allegation is that Meta is actively blocking third-party AI agents from integrating into the WhatsApp business platform, specifically to favor their own Meta AI assistant.
So if I'm a local business in Kenya or Egypt, I can't use a locally developed AI customer service bot on my WhatsApp channel. I'm forced to use Meta's AI.
That is the exact concern the commission is investigating.
Mm.
And this matters immensely because in many of these 21 countries, WhatsApp effectively is the internet for small businesses. If you control the AI layer on WhatsApp, you essentially control the digital economy.
It's a digital sovereignty issue.
Completely. If Meta loses this probe, they might be legally forced to open up the WhatsApp platform to rival AI agents in some of their fastest-growing global markets.
And then, pivoting back to the US, we had some old ghosts resurfacing this week. Project Name Tag.
Yeah, this one made a lot of waves around the 15th. Several outlets reported on an internal project codenamed NameTag, which is an effort to bring facial recognition technology to the smart glasses.
Wait, I thought they completely killed their facial recognition programs back in 2021. Didn't they make a big deal about deleting 1 billion face prints?
They did, but the functional allure of the tech is apparently too strong to ignore. The reported idea with NameTag is that your smart glasses could seamlessly identify people in public as you look at them.
I mean, that sounds incredibly useful and absolutely terrifying.
It really is the ultimate privacy dilemma. Never forget a face again is a brilliant product tagline, but the end of anonymity in public spaces is the dystopian flip side of that exact same coin.
And adding to the controversy this week, there were unsealed court filings from a lawsuit in New Mexico regarding children's safety.
Yes, these filings allege that Meta's leadership, specifically including Mark Zuckerberg, explicitly approved rolling out AI chatbots for minors despite internal warnings from their own safety teams. The sources report those warnings flagged that the bots could potentially engage in inappropriate or even romantic interactions with kids.
Wow. We should note that these are allegations in a lawsuit, but that is a really bad look when you are simultaneously trying to pitch your AI ecosystem as safe, helpful, and responsible.
It heavily undermines their safety-first public narrative. It suggests to critics that when push comes to shove, user engagement metrics might still override proactive safety concerns. And honestly, that connects directly to the massive lobbying story we saw.
Right. The New York Times piece on the 18th, they reported that Meta is launching a $65 million political campaign.
$65 million specifically aimed at supporting candidates who are favorable to AI innovation. They clearly view impending regulation, especially a patchwork of restrictive state-level laws, as an existential risk to their roadmap.
So they're willing to spend heavily to shape the legislative environment so they can keep building as fast as possible. It's basically a defensive perimeter of money.
Essentially, yes. They're building the physical infrastructure with the NVIDIA deal, the software infrastructure with Llama, and the political infrastructure with this $65 million war chest.
So bringing it all together as we wrap up, we have a week where Meta is aggressively solidifying its foundation on every front. They're locking in the gigawatt compute with NVIDIA. They're locking in the global developer base with Llama 3.3 and Infra-RT. They're locking in users in India with heavily localized performance hardware.
And at the exact same time, they are fighting off regulators on multiple continents who are trying to slow that momentum down. It truly is the industrialization of intelligence. We are moving way past the, wow, look at this cool chatbot phase into a, We are rebuilding the global computing infrastructure phase.
It certainly feels that way. I mean, the Xray-Visual model alone, processing 15 billion messy images natively, just shows the sheer, unimaginable scale they're operating at right now. It's almost beyond human comprehension.
It is, and honestly, that leads to a pretty provocative thought for our listeners to take away today.
Let's hear it.
We talked about Project NameTag, the leaked facial recognition on the smart glasses, and we talked about the NVIDIA deal, the gigawatt-scale centralized computing power, and the Spectrum-X networking. If you combine those two developments, are we moving toward a world where your glasses don't just see the world around you, but they actually index everyone in it in real time? Because if Meta has the compute power and the algorithmic efficiency to process 15 billion images for a training run like they just did with Xray-Visual, they certainly have the power to process the faces of the people you pass on the street.
That's a heavy thought.
It is. The question becomes, is the personal convenience of never forgetting a coworker's name worth the societal cost of never being a stranger in a crowd again? Because based on the actual physical and software infrastructure they deployed just this week, that capability is not science fiction anymore. It is simply a policy decision.
And as we just saw with that $65 million lobbying push, they are working extremely hard to make sure they are the ones shaping those policies.
Precisely.
Well, on that note, we are going to wrap up this deep dive. As always, check the sources we mention if you want to read the ArcSIF papers or the legal filings yourself. We impartially report what's in them, but it's always good to look at the primary documents.
Absolutely.
Stay curious, stay informed, and we will catch you on the next deep dive.
See you next time.